Yeah, hi everyone. Today we will discuss about the working principle of shaper machine. The last video, which I have shared in my playlist, we have discussed about the different parts of a shaper machine. And this is the shaper machine. And here you can see there is a tool hedge, and immediately below the tool hedge, we will attach the tool. And this is the work table. And here we would place our workpiece which needs to be machined. And laser, again I am repeating, sorry, shaper, I am repeating, it is actually used to machine the surface. So definitely the tool needs to travel in this particular direction. This is called reciprocating motion. And what actually gives the tool the reciprocating motion is called the working principle of shaper. And this one is called ram. This one, this ram is connected to the column. This one is the column, and column has a mechanism uh, which consists of gears, and it can give a drive to the ram. That is, in we need to convert the rotary motion of the gears into the reciprocating motion. That is explained by crank and slotted lever mechanism. Here you can see a schematic of the shaper machine, and this schematic, it is explained in detail in my earlier video, and which I have shared in my playlist also. Those who have not watched that particular video, just you can, it is available in the playlist. And this part is called column. Here you can see this one. This part is called column, and this one is the ram. And I have mentioned earlier, column consists of some arrangement which will be having some gears. That rotary motion needs to be converted to reciprocating motion of the ram. Then only I can get a reciprocating motion to the tool so that I can machine this particular surface. And that mechanism which converts the rotary motion available in the column to the reciprocating motion of the ram is called crank and slotted lever mechanism. And we will see what exactly a crank and slotted lever mechanism is. Crank, as all of you know, that crank is something which rotates. Definitely it should be a circular, it will move in a circular pattern, right? If it is gears also, definitely the motion will be circular. So crank is actually a circular wheel. What is actually slotted lever then? Slotted lever is nothing but a rectangular shaped uh, lever with a slot inside. Here you can see this is actually a link which connects the slotted lever. This is actually the slotted lever, this black colored one. And this slotted lever is connected to the ram by a link. This is the link, this one. This is the connecting link which connects the link, connects the ram and the slotted lever. And so we have seen crank, slotted lever, and the link which connects the two. Definitely, the next thing is we need to attach or fix the slotted lever inside. So slotted lever is fixed using another fixed link. This one is another link and it is fixed. This one is the fixed link. And the crank is also attached to that. And next thing is this particular crank will rotate, and this slotted lever, what it needs to do, it has to give ram the reciprocating motion. For that, there is actually a slider inside. This is called the slider, this one, a slider inside the slotted lever. This slider is connected to the crank. Okay, so here you can see when the crank rotates, what happens? This slider will make a reciprocating motion inside the slotted lever, and slotted lever will move like this. from here to here. But since slotted lever is attached to the ram through this link, what happens is that when the crank rotates, the slider moves up and down in such a way that the slotted lever will move like this, extreme positions. That means it will pull the ram to this side, again to this side. So the extreme positions. So this is the movement. See. So here you can see this is the extreme position where the slotted lever can move to this side, and this is the extreme position to the left side. So if I can join these two, this will actually pass through, or it will make a tangent to the crank. So these are the extreme positions. This one is the extreme position, this one is the extreme position. So when you rotate the crank inside the column by some mechanism, what happens is that since the crank is connected to a slotted lever through a slider, the slider will reciprocate. And since the reciprocating motion of the slider is there, the crank, the slotted lever will oscillate in such a way that it can go to two extreme positions, either this side or this side, such that the reciprocating motion of the ram is achieved. Got the idea? And here you can see this portion, that is this one. If I'm just dropping perpendiculars, sorry, if I'm just dropping perpendiculars from this side and this side, this angle is obviously an obtuse angle, right? If I'm marking this angle by beta and this angle by alpha, beta is more compared to alpha. So definitely the cutting stroke is the forward motion of that is, this is the cutting stroke. Cutting stroke is in this direction, right? Cutting stroke. And return stroke in this direction. Return is in this direction. So cutting stroke is beta. That means it can move, the ram can make a reciprocating motion equivalent to an obtuse angle. That is, the cutting stroke is more while the return stroke is less because it is an acute angle. So why this particular arrangement means, during cutting stroke actually the machining happens and the return stroke is idle, right? Cutting stroke machining happens and the return stroke definitely it's idle. So since the return stroke is idle, if I can reduce the time for the return stroke, definitely I can increase the production time or the machining time because return stroke is idle, right? This is called crank and slotted lever mechanism, or it is called quick return. Quick return means it is making the return stroke faster. Quick return motion mechanism. So when a question comes like explain the crank and slotted lever mechanism of a shaper or the working principle of a shaper, you can draw this particular figure, that is the crank and the slotted lever, and you can make your own justifications for that. Okay, so we will meet again with another video. So thank you.